Good evening, Derrick Pitts, Chief Astronomer at the Franklin Institute here for Night Skies at Home, part of the Franklin Institute's Franklin at Home series of science programs in which we bring you all sorts of great science activities that you can do right at home. And of course, with this program, it's all about astronomy. Again, this is the fifth version of this that we're doing, our fifth session. And during this time that we've been together doing this, it's been a really interesting time for us in terms of getting outside to see the night sky. If you were with us for the first program we did, you'll be relatively clear, but the problem, of course, was that we couldn't actually, we couldn't really do very much because of the fact that it was so windy, and that made it really breezy. That made it really difficult. So let me just check and see. I want to just check and see that my audio is coming through for you okay. Is my audio coming through for everybody okay? Just checking to make sure. Give me a thumbs up if you can hear me.
Sounds good. It's going in and out from
Sounds good. It sounds like it's going in and out, huh? Well, let's see if we can correct that. We're just going to give a little test here and see if we can get it to a point where we have no problem. So let me know and we'll keep going anyway. Well, anyway, for
She said it's better.
Say it again, I'm sorry?
All good and better.
Thank you. I'm just checking with my producer over here. Okay. Okay, great. All right. The sky was clear, but unfortunately, we've had very, very high winds, and that made it really difficult for us to hear really well since I was outside that evening. But can you believe every night since then, it's either been really, really windy and cold, mostly the windy part. I don't worry so much about the cold, but it's also been very wet. So for the last 3 weeks, it's been wet. And tonight is no different here in the Philadelphia area. We have lots of heavy rain and very, very high winds tonight. So of course, we're not going to be out this evening, but that's okay because we still have lots of great programming. This great programming we're going to take tonight. Starting out with our program in just a moment. We're also going to have a great chat with Dr. Sian Proctor, a friend of mine who's going to join us tonight to talk about her experiences as a geoscience professor, an analog astronaut, and author and a science communicator. We'll talk to Sian in just a few minutes, and then we'll come back and we'll talk more about your questions. We'll also have a chance to talk about what's going to be coming up for visibility in the night sky in the next week, what stuff is great to see in the evening sky. We'll talk about International Space Station visibility. And we'll also talk about what next time around. So what we're going to do here first is we're going to get started with your questions. We'll get started with your questions first. So while you're getting your questions together and sending them in, here's what I'm going to do. I'm just going to remind you that this program is all about you becoming a regular sky watcher. This is something that you can do anywhere. You can do it right from home without any difficulty at all. You can do it no matter where you are, and you can do it with your family with no equipment. If you have some lightweight equipment, gee, that's great too, but it doesn't really take very much to get this done. It really just requires these two telescopes you have here, these one power telescopes, are all you need really for this. And there's so much that you can see without any difficulty at all. You can see all of the bright stars. You can see a number of bright planets without too much difficulty. You can see all the main constellations, even if you're in an urban environment. You can see all the main constellations like meteors and meteor showers, as well as International Space Station and some other bright satellites. In fact, we're going to do a little bit of a section later in which I take you on a walking tour through that program that I keep talking about, Stellarium. We're going to do a screen share of that. I'll walk you through that and show you a little bit of what that looks like. But now, let's take some questions if you have any questions. No questions yet? Okay, great. So let's just go on to this part. We'll get this piece covered before we get on to Sian coming up in just a few minutes. So What's available for us to see in the sky right now? Well, it goes like this. The sky phenomenon right now for this time of year, sunrise now comes at 5:59 a.m. So now the sun is rising just ahead of 6 a.m. And that means we're gaining more and more minutes during the course of the day. We're now up to 2 minutes and 15 seconds a day. We've been advancing pretty quickly since the first day of spring. And now what's happening is that the number of minutes and seconds that we are gaining every day is starting to decrease as we head toward the first day of summer. Now, it also happens that we're at a very interesting point coming up tomorrow. Today is April 30th. Tomorrow is what? May Day, May 1st. Well, why is May Day considered to be such a recognizable day on the calendar or in astronomy? It doesn't have anything to do with something you can see in the sky at that particular time, but it actually has to do with the calendar more than anything else. May 1st has been recognized for hundreds, even thousands of years as May Day. Some cultures celebrate with dancing around a maypole, lots of other days, but it's the recognition of this day. And the reason why is because May Day marks the halfway point between the first day of spring and the first day of summer. So that particular day, that halfway point between the first day of spring and the first day of summer, in fact, the halfway point between any two seasons, believe it or not, you already know all of the cross-quarter days. Well, most of the cross-quarter days. Let's go around to the halfway point between the first day of fall and the first day of winter. There's a special holiday in there that we all like to celebrate. We love to have a good time on this particular day. And as I said, it's halfway between the first day of fall and the first day of winter. Can you guess what that is? Sorry, I don't have the Jeopardy music to play in the background for this, but you can imagine what that sounds like in your head. If you're guessing Thanksgiving, you've gone too far. Come back to the beginning of November, actually the end of October, October 31st, Halloween. Halloween is a cross-quarter day. It marks the halfway point between the beginning of fall and the beginning of winter. Now, there's another cross-quarter day that you know that's halfway between the first day of winter and the first day of spring. There was a very end, and it's about a situation that kept repeating itself over and over and over again. Not Valentine's Day. No, one day of that is enough. Thank you very much. No, really, it's actually Groundhog Day, February 2nd. February 2nd is a cross-quarter day between the first day of winter and the first day of spring. Now, why are cross-quarter days important? Well, they aren't so important to us anymore in our modern society, but in much earlier societies, these halfway points were really important because they were important to the agricultural calendar. And the reason why is because if we can divide the day or divide the year into these smaller parts, it makes it easier for peoples back at that time to keep track, important because you wanted to be able to plant crops and harvest crops in a timely fashion that would assure that you would have enough food to last you through the harder parts of the year. So it was really very important to understand how the year was broken up. And this was one way in which that was done, to use cross-quarter days. So tomorrow is a cross-quarter day. Sunrise tomorrow is at 5:59 a.m. Sunset now is coming at 7:55 p.m., just before 8 o'clock. We have a long way to go in terms of time before we get to the longest day of the year, coming up again around the first day of summer. Moonrise now is at 1:04 in the afternoon. 1:04 tomorrow afternoon, the moon rises, and it sets at 3:29 a.m. on Saturday morning. It's just past first quarter, so tomorrow night and the next 3 nights after that are going to be excellent nights for viewing the moon, especially if you're going to view with binoculars. And if you had a chance to catch the little video piece that we started just before the program, that was a NASA visualization that was set to the music of Claude Debussy, Clair de Lune. And in that video, you could see really gorgeous detail on the surface of the moon. This comes from images that were taken by a satellite orbiting the moon, taking very, very high resolution images and arranged into this visualization. But guess what? Your binoculars are going to show you a lot of great stuff if you get out and use those to look at the moon. So like we talked about last week, this is a regular pair of house binoculars. Let me just check and see what the power is here. Oh yeah, these are 8x40, and I explained last week, the 40 relates to the diameter of the lens on the front, 40 millimeters, and the 8 refers to the magnifying power of the eyepiece here. So you really have two telescopes next to each other, and that's what makes them binoculars. So 8 power with 40 millimeters light gathering capability, you'll be able to see really, really great detail on the surface of the moon with these. All right. Okay, great. We have questions now. So let's get our first questions in and we'll start there. What do we have so far?
Is there anyone in space right now?
There's a great question. Is there anyone in space right now? Yes, there are 6 people in space right now on board International Space Station. And the next time International Space Station becomes visible, which I'll actually tell you, is there are lots of flyovers coming up this week. That provides an opportunity for you to go out and wave at them as they go by. If you want to find out who's on board, it's very simple. If you go to nasa.gov and click on their space station link, you can find out who's on board right now. And it's fun to find out who's from what country, what they're doing, and you can even look at some of the live video on board International Space Station. So that's an easy way to see that. What's up next?
Venus and the moon are going to be seen in a unique pattern, thought to be a smiley face. Do you know when that will be and why it'll be in that shape?
Well, that's an interesting question, and I'll tell you why that's an interesting question. This poses the question about Jupiter, Venus, and the moon being together in the sky in a unique or positioning. And that's an unusual question. It's an interesting one because right now, Venus happens to be high in the west in the evening sky. Now, the moon has been creeping past it the last couple of days. These days earlier in the week when in the Philadelphia area, it's been so cloudy and we haven't been in Venus. Now that's going to happen month after month as Venus is still in the western sky. But Jupiter is over in the morning sky, in the pre-dawn sky, visible at like 3:30 in the morning, 4 o'clock in the morning. So if I'm thinking about this correctly, it's going to take a while before Jupiter makes its way around to the evening sky. In fact, that's not going to happen until summer. But we have to watch out about how Venus and Jupiter move against each other because Venus has now reached its point in the sky where it's at its brightest. And so that position is going to start to change as it comes back down toward the sun. So it's going to be a little while before those two actually get together. I'm not going to advocate going out to look for that right now, but as we get closer to the date when that's going to happen, I'll be sure to bring that back to your attention. I can tell you for sure, though, that's not going to happen for at least another 1, 2, 3.5 months. So hold on to that. We'll come back to it. Okay, one last question before we jump out to visit with Sian.
Okay, young Valletta would like to know, was a study that showed that Einstein's theory of relativity, not Newton's law of gravity, explained the movements of a star around a black hole. Can you talk a little about that?
Wow.
Did Newton even know about black holes?
Well, wait a minute. Let's go back to the first part of that. Young Valletta wants to know.
Yes, he would like to know why a black hole sucks up everything.
Okay, let's hold on to that one. So the question is, why do black holes suck up everything? It's because they have very, very intense gravity. That's the reason why they suck up everything. Imagine taking a star in diameter, and you squish that down until it's about the size of the moon, or maybe even smaller than that, certainly smaller than that. Well, it still has the same pulling power as the 1 million mile diameter star does. And so that means it has the capability to suck things into it. So that's the reason why black holes suck things in. They have really, really, really intense gravity. And then the next question that went along with that was,
did Newton even know about black holes?
Oh, did Newton know about black holes? No, Newton did not know about black holes in his time. He was the person that helped us with the mathematics, that helped us to understand gravity, and that's really great. That's really wonderful. But he did not know about black holes specifically. It would have been possible for him to calculate out what could have happened if you had an object with an infinite amount of gravity. He could imagine what that would have been, but he was not aware specifically of black holes himself. Okay, so great. Thank you for those questions. We're going to do more of your questions later, but right now, we're going to bring my good friend Sian Proctor in. And Sian, I'm going to ask you if you'll just start talking for me for a second so I can check my audio and make sure I can hear you.
Derrick, can you hear me okay? Derrick, can you hear me?
I hear you. Let me just do one thing here. Hold on. Wow. Isn't this fun? There we go. Okay, now we've got it all together. Can you hear me, Sian?
I can hear you. Every once in a while you freeze on me, but then you come back. So should be okay.
Wonderful. Thank you so much. Okay, so now, everybody, I would like to introduce you to my good friend, Dr. Sian Proctor. Sian is a geoscience professor at South Mountain, and we're going to find out what that means in just a moment. She's an author, and she's a really, really great science communicator. She's appeared on many different science programs, including Curiosity Stream, Genius by Stephen Hawking, Strange Evidence, NASA's Unexplained Files, Tube Channel, Dr. Sian Proctor. Get this though, she's also an astro chef because she has authored her own book, her new book called Meals for Mars. Thank you very much for joining us, Sian. Oh yeah, there it is. Fabulous.
Thanks for having me, Derrick. It's a real pleasure to be here and talk to everybody tonight.
Great. I'm glad you could do this for us tonight. So what I'd like to do, Sian, is I want to cover your experiences as an analog astronaut to start with. And the reason why we're all in a sense, acting coronavirus quarantine that many of us are in. So tell us about in which experiences you got to play the role of analog astronaut.
Yeah, it's really kind of interesting because I've done a couple of things that are analog astronaut. An analog astronaut is someone who does human spaceflight research, but on Earth. So for me in particular, I live in Moon and Mars simulations kind of a lot. I've been in 4 of them so far. And so I lived in the high seas habitat. This is a 3D model of it right here, but it looks like this.
Wow. About how big was that, Sian?
This dome is about 900 square feet, and 6 of us lived in it for 4 months together, investigating food strategies for long duration spaceflight for NASA.
Not a lot of room, Sian.
No, it's not. But what's interesting about it is that if we left the habitat, if we went outside of the habitat, we had to wear a spacesuit. And you didn't get to go outside a lot. And we were in an area, we're on the big island of Hawaii, on the slopes of Mauna Loa, about 8,000 feet high. And if you went outside, again, you had to wear a spacesuit and there was nobody. So you weren't interacting with people. And so that's why this situation is very analogous to that, in the sense that you're isolated in your house or your apartment. And when you go outside, you're trying to social distance from each other.
And the idea of doing that simulation was to help gather data, to help NASA figure out what kinds of challenges astronauts would have going out to explore deep space to places like the moon or onto Mars.
That is correct. And so NASA's really interested in how crew cohesion is a big thing. How do you assemble, people from across the globe and put them in a really tiny place for a long duration and have them get along? And we can think of that as the International Space Station is an example of what's happening now. But when we go to the moon and then to Mars, we're not talking 6 months or a year, we're talking multiple years. And so NASA really wants to make sure that people will be able to cope with that, and looking for strategies in how to do that. And so there are analogs around the world that contribute to this type of research.
Wow. Okay, cool. So now how long were you in that particular one again?
I lived in a high seas habitat in 2013 for 4 months.
Wow. So now what was the most difficult part about doing that?
I think the most difficult part is it was a Mars simulation. So because of where the Earth is and Mars are at any one time in space, you can have a 20-minute delay in communication back at home. Nothing is in real time. It's all delayed. So you can imagine me sending you a message, Derrick, and it will take 20 minutes for it to get to you. By the time you read it and respond and send it back to me, it's at least another 20 minutes. And so big delay in communication.
Wow, that's a real challenge. Huh. So now of that experience and other experiences you've had, you would give everybody this evening about how to best survive a like this one we're in now.
You know, this is one of the things that I learned is that it's a good opportunity to think about the things that make you happy or your resiliency, the ways in which you can, it's a good opportunity to grow and find new habits and crafts, because that's typically when we go into these analog situations, we're developing, a lot of times you have these habits already created, but it's a good way to kind of regulate yourself and really get to know the things that make you happy, the things that make you sad, how to bring yourself out of that, how to be more resilient, how to be adaptive, all of these kind of characteristics because you're in this stressed environment. But it's so important that when you start to discover these things about yourself, that you figure out how to regulate and move forward. Because a lot of times if you get stuck in these situations, you get bogged down and you don't know how to, you know, move forward. And if that happens, it's really important to reach out to somebody, somebody that you can talk to, that again can get you back on track and keep you moving forward.
Sure. Okay, well, that's great. I hope people will be able to make some use of that information that you provided, because, you know, that's even, you know, our situation here is seriousness of the virus that we're dealing with, but at the same time, we still have to figure out how to work, how to best deal with the quarantine situation we have, so that we can make the best of it for everyone around us whom we want to
Right.
protect from infection.
It's a question for her.
That is so true. And so thinking about how, you know, how do you still positively contribute, but also take care of yourself and your family and your friends in this very stressful, unique time. But even though we're social distancing and isolating, you still have community, and figuring out how to connect with your community, similar to what we're doing right here.
Yeah, that's true. So hopefully we'll be able to make use of this information. This information will be helpful to people as we try to make our way through this. So now let's talk a little bit about, you know, your, you know, part of the reason why this kind of work has been important to you is because you were a finalist in 2009 for the 2009 NASA astronaut class, weren't you?
That is correct. And so I was really fortunate to apply to be an astronaut in 2009. And out of about 3,500 people, I got down to a yes/no phone call for 7
Whoa.
finalists. And they only chose
Wow.
9 that year. I'm convinced if they chose maybe 15, I would have made the cut. But
Oh,
they only chose 9.
I'm
And
sure you would have been number 10.
that's exactly right. That's what I told myself, right? And so that was a really amazing experience. It really rekindled my love of aviation and aerospace. Mhm.
Of course. That's pretty much what you do right now, is help people learn about astronomy and space exploration.
Yeah, so I've been a community college professor for over 20 years now, geoscience, teaching geology, mainly historical geology, physical geology, geologic disasters. But as my career has expanded and I've been able to do more things in space and human space exploration, I've been able to offer more classes like Intro to Planetary Science and Life in the Universe. And so, and things, and also sustainability classes, sustainable Earth, and I mean, sustainable world and sustainable cities. Because one of the things that I like to say is solving for space solves for Earth. And so that connection.
Very cool. Very cool. I like that. Solving for space solves for Earth. Yeah, we should all take that away with us. So I do want to get, and this does connect really nicely through all the experiences that we've talked about for you so far, out to your book about cooking for space. However, before we do that, I want to stop a little bit along the way because, and this is particularly important for the young explorers in our audience, because you also are a really serious geo-explorer. I think every time I reach out to talk to you, you are on some other expedition somewhere else on the planet.
Yes, I definitely, I call myself a geo-explorer. I love to travel and investigate new things. And my whole thing is that a lot of times when we talk about being a modern day explorer or exploration, people think that you can only be an explorer if you discover something new to humanity, something that's never been discovered before. But I actually think that you can be your own explorer. So if it's new to you, then you're an explorer. So I call myself a geo-explorer. I try to travel the world and do really fun, interesting science investigations and learn new things for me. And so I've been a polar trek teacher to Barrow, Alaska, doing climate change. I have been a NOAA teacher at sea to Kodiak, Alaska, doing research on pollock fisheries. I've been on the Joides Resolution, a drilling ship that travels the world, drilling core samples from the bottom of the ocean floor. Yes, really interesting things. I've lived in 4 Moon, Mars simulations at different places, just really pushing myself, but also just hiking. I hiked the Camino de Santiago. I don't know if you've ever heard of the Camino de Santiago.
Where's that?
The Camino de Santiago is in Spain, and it's a 500-mile trek across northern Spain when you start in France and you go over the Pyrenees, through Pamplona, and all of these places to Santiago de Compostela, the resting place of St. James. So this has been a famous pilgrimage for thousands of years.
But Sian, you've only done this because of your extreme interest in doing these things. I mean, if I remember correctly from discussions we've had, you're just really excited to be able to explore the world. And this is something that kids everywhere can do, right?
Oh, yeah. Yeah, then no different than me. When you travel and you meet other cultures and you meet other people and you taste the food, it just changes your world in a way that it's hard to express until you've done it. And so Derrick and I met because we're Astronomy in Chile educator ambassadors, and
right.
we met in Chile.
That's right, we did.
Yeah, and so going to the Atacama Desert, this really high altitude desert, something that you just can't even imagine.
Had you been there before, Si? You hadn't been there before either. Yeah, right. So it was a really extraordinary experience.
It was, and just the people and the culture and the landscape, it's just, those are the kinds of things that just fuel my soul. And so one of the things that I like to do is travel to these amazing locations and then bring all of that information back to my students.
Oh, yeah.
To blog about it, to put it online, do YouTube videos, and just inspire the next generation of geo-explorers and astro-explorers.
Yeah, that's really great. You really do want to encourage them to be explorers too.
Yeah, because the world's just waiting for you. And when you take advantage of the opportunities, that when you have those opportunities and take advantage of them, it really changes your world. And there's this ripple effect that you don't even realize. One thing leads to another thing, leads to another thing.
Absolutely. You're certainly right about that. I know all about that. So, Si, tell me, when you were a kid, did you explore around your neighborhood?
I definitely, I was what you would call a tomboy back then. Now that word, because you can be a tom girl and, you know, or a Jane or anything.
Right. Yeah.
But my mom had fond memories of me catching salamanders and running through the woods. And as a kid, I loved military aviation and building model airplanes,
Mhm.
looking up at the night sky. And I remember getting my first telescope as a kid, just tracking the moon, all of those things, just curious and wanting to know, asking
So
questions.
this was all about feeding your own curiosity.
Oh yeah, you know, one of the things that I try to tell my students is that, and to lead by example, is to be a lifelong learner. I am always asking new
Yeah,
questions and
absolutely.
pushing myself to learn new things.
Mhm.
And a lot of times that my students will ask me, well, weren't you afraid to go on a drilling ship? I live in Phoenix, Arizona, a desert. Like, you could go spend 2 months in the Antarctic circumpolar current in the wintertime. And I'm like,
Yeah.
yes, I may be a little afraid that I'm going to fall overboard in this deadly weather and this, you know, this, if you fall overboard, you die because it's so cold. But it doesn't
Yeah,
stop
right.
me. It doesn't stop me from going because the narrative in your head makes things a lot more extreme than they often turn out to be. And
Mhm.
so I try to put that in check. I tell my students I do have fears, but I don't let my fears rule me. I manage them, and I think about how realistic is that fear. And even though I can talk about it being a small probability of me actually falling overboard,
Mhm.
um, I can put that in check and move forward and have that experience and be like, wow, this has been fantastic.
Yeah, that's really wonderful. That's a wonderful way to describe how you can try to analyze or figure out the risk that's involved in something and assign it the proper value so that you can sort of push ahead. So it sounds like debug, and I'm hoping that some of the younger viewers that are listening to us here realize that they should feed their curiosity in the same way that you've been feeding your curiosity and just keep on going with that.
Oh yeah, and there's so much to learn and explore, and even in your house, things that you can experiment with. You can take things apart, try to put them back together.
Oh yeah,
Uh,
that's
yeah,
fun.
reading, you can go places with your imagination.
Absolutely.
And the more that you practice something, the better you get at it. So whether it's, you know, art or music or learning how things go together, building things. And so I didn't grow up with a lot of Legos, and I have a Saturn V rocket behind me that my brother sent me for my birthday this
Well, I
year.
see that back
I can't
there.
wait to put it together. And
You know,
so
I think that would look way better over here on the shelf behind me.
and so it's little things like that, and it's not about even though I'm an adult and stuff,
Mhm.
I love things that I love to play, and I love to bring that child that's within me and fuel the soul of my inner child, I guess I would say.
Yeah. Right, okay, so now we have a question for you.
Lots.
So I'm gonna read the question to you. My producer is gonna feed me the question. I'll say it back to you, and then we'll give you a chance to answer. Okay, and then after that, we're gonna go dig into what it's like to prepare meals for Mars.
Sounds good.
Okay.
Would a spacesuit keep you nice and warm during the cooler months? It's from a kid.
So the question is, I don't know if you could hear it, Sian.
I could. And yes, spacesuits are designed as your own kind of ecosystem. So they're designed to keep your body safe from whatever temperature extremes are out there, but also to regulate your airflow, monitor your systems, all of those things. So you can think of it as your own personal life support system, protecting you from the elements around you, the temperature, anything that could pretty much kill you, that suit is trying to protect you from.
You've been inside a spacesuit, haven't you?
I have been inside a pressurized spacesuit as part of Project Possum. And so this is one of the patches that I have. And Project Possum
Ooh.
is you do an investigation in the suborbital sciences, upper mesosphere, looking
Mhm.
at clouds. And so one of the things that some of the companies are trying to do is bring commercial space by launching people up just outside of, low Earth orbit, and then you come back down and you land.
Oh, sure,
And
yeah.
yeah, and there's these things called noctilucent clouds up there in the upper mesosphere that are really interesting to look at and to analyze. So to do some of that science.
Yes. Is there another question?
Oh, yes, absolutely.
We'll do one more, Si.
Well, we have quite a few. What kind of projects is NASA working on to utilize renewable energy and materials, and how could it change future space exploration?
Oh, very good. One of the big things when you're talking about renewable energy, solar is a big part of spacecrafts, and harnessing, there's no better energy than that big ball in the sky, our sun, our star.
Indeed. Right.
And the more we can get the technology to be efficient in solar energy, the more we can not only do really cool space exploration with it, but also improve our energy resources here on Earth. And so mathematically, it's been shown that we should be able to get up to 85, maybe even 90% efficiency in solar energy, but right now we're only at about 20, 25%. So we know we can get there, but we just got to get the technology to the point where we can become even more efficient.
Yeah, you're right. There's a lot of room for improvement in the solar realm of things and what NASA's doing. Si, can you also talk for just a moment about how reusable launch vehicles are now really making a huge change for how we access low Earth orbit, and how that sort of plays into the efficiencies we're starting to see?
Yeah, the whole idea of anytime you can reuse something, not only is that good for us and the environment and resource management on Earth, but it reduces the costs of things. And that's so important, especially if we want to open up space and have access to more people experiencing space. I know we are. Derrick, you want to go up, right? I know.
Hey, let's go. Absolutely.
And so the biggest barrier is, how do you get out of the gravity well of Earth? And it's all about the weight. It's all about being efficient, and reusing materials is part of that equation. And when you're at home, you can think about this too. We generate a ton of waste in multiple ways. And so how do we start to be more efficient with our own waste so that we can help the environment?
That's great. Yeah, these are all important factors when we consider what it's going to take to make it easier for us to access low Earth orbit and space in general, and that efficiency is really going to be a major piece of it. Speaking of exploration, it's no fun traveling anywhere unless you have good food to take with you or good food to eat when you get there. So
true.
I know you have a plan for making sure that we can eat well as if we were on Mars, or when we go to Mars. You've got this great book. Let's see that cover again, Si. There it is, Meals for Mars. I don't know if everybody can read that. An analog astronaut living and cooking in a simulated Mars mission. That's a fantastic cover. So tell us all about this.
That's cool.
Yes, so I was really fortunate to live in, again, the high seas habitat for 4 months, investigating food strategies for long duration space flight. So this was funded by NASA specifically to look at food. And so, Derrick, I spent 4 months switching on 2 days eating like astronauts eat now for the most part, which is just add water and heat meals, versus being able to eat 2 days of creatively cooking, where we use things like freeze dried meats, vegetables.
Oh my goodness.
Yeah, so this is freeze dried chicken. This is freeze dried corn. These are freeze dried blueberries. And so what happens is, in this process of freeze drying, is that things like corn and your vegetables, 98% of the water is taken out of it.
Let me have one of those so I can taste it. Okay, thank you.
and they're actually really delicious to taste. But when we take out the water, it becomes shelf stable and becomes shelf stable for a long time. And what you can do is it also reduces the weight. And we know weight is really important when it comes to taking things up into space.
Yeah,
And so
absolutely.
NASA is really interested in when we go to the moon and we go to Mars, even if we have a little bit of gravity versus going to Mars and we have a third of Earth's gravity, can we have astronauts cook? And if we have them cook, how efficient, what does that do for morale? Think about the way cooking impacts us as a
Oh,
culture
yeah, absolutely. Sure. Right.
and how
Yeah,
important food is.
it
And
is.
so one of the things that I was really interested in was how we can take that information and package it in a book for people to be able to see recipes and some of the interesting things that we cooked. And so I'll just put up a couple of pages for you just so that you can see some of the interesting things.
Hey, Cyan, why don't you try this? You know, when we're talking about how food is such an important part, things like that, the first thing that comes to mind for me are comfort foods.
Yes.
So is there a recipe in your book that you would recommend as like a comfort food?
Yes, I absolutely have. Well, I think people would really like, I know a lot of people love pasta, and this
Sure.
is a great recipe. It was a lemon pasta dish that we created. But another one that I really want to share really quickly here is, a lot of times people don't think about this, but dessert. How many of you like dessert out there that's listening?
What are you talking about? We think about dessert all the time.
And so
We start there.
Little things like it just in isolation now. Derrick, are you snacking? What are the things that you're eating and are kind of drawn to under this kind of stressful situation?
Oh, yes, definitely snacking. You're right. And I really have to work hard to not overdo it and really regulate, my caloric intake and my energy output so that, my belt will still fit around my waist after this is all over.
Well, that's why I love the freeze dried, because it's healthy, like this corn, and it tastes really good. I can just eat it as a snack. And a
Hopefully,
lot of people,
go ahead.
yeah, a lot of people will recognize freeze dried food. So if you like fruit in your cereal, that fruit is freeze dried and it gets rehydrated when you add water or your milk, I should say. And so these are blueberries here.
Oh,
And so
they
if I
look
want a
good.
snack, I can just grab my
Oh, they're
blueberries.
crunchy.
Yeah,
Yeah.
they are crunchy.
Ah, how
And
about
so
that? Okay.
when you go to your grocery store now, you're probably noticing that there's freeze dried fruits that are now easily available for you to buy. And
Right.
it's only a matter of time that you're going to start seeing more freeze dried vegetables and then eventually freeze dried meats.
So what this means, Cyan, is it also means that the way in which astronauts eat is changing from the way in which their meals had been prepared in the early days of space exploration and even up through the space shuttle era.
Right.
It seems as if the way in which food is prepared for astronauts is changing still and becoming much more home-like than it was before.
Right. And on the ISS, because of the situation with gravity, they still like to package these meals, but NASA has a whole suite of nutritionists and cooks that are dedicated to making tasty meals for the astronauts. So anybody listening out there, especially our young viewers, you can be a space chef. And as we start going to the moon and then onto Mars, it's going to become even more important. And you could be a cook on the moon or, a chef on Mars. And so these are some of the things that are going to be happening and hopefully in our lifetime.
Hopefully in our lifetime. So now your book, Cyan, are the recipes in your book meals that you have identified as meals that are easy to prepare, nutritious, and could be done in an off-planet environment, or are they meals that you and your colleagues were preparing inside the high seas habitat that you've now brought out to share with everybody else?
You know, this is a really interesting question, Derrick, because I was the education outreach officer for this mission. And it was a brand new Mars analog location, never been lived in before. And so I was given the task of letting people around the world know about this new mission and the analog site. And so I did a recipe contest before we went into the high seas habitat. I put a shout out around the world saying, hey, here's my space pantry that we're going to have in the high seas habitat, listed all the ingredients. And I said, we have 5 categories, submit a recipe. And if yours gets selected, then we will cook it. I ran a cooking show called Meals for Mars while I was in the high seas habitat. And I had a different crewmate every week that would come in and cook with me. And we would cook people's recipes from around the world. And so that's what is collected here, is those recipes that people submitted.
Wow, that's fantastic. That's really great. So now, how do we get the book? Maybe you didn't hear me?
Yep, mealsformars.com is the website, mealsformars.com. And right now I've got a new recipe contest because of the COVID situation and isolation. It's called Meals for Earth. And again, we have 5 categories of soups and stews, breakfast, main meals, snacks, and desserts. And the top 5 in every category is going to get a digital copy of my Meals for Mars cookbook, but the top recipe in every category gets a signed autograph from me.
Ooh.
And anybody who submits will get a Meals for Mars patch sent to them. So just by submitting, you get something. And I will tell you, we just extended the deadline till May 31st. And because not a lot of people have submitted. So if you're a cook or a baker, submit a recipe because you've got a good chance of winning.
Wow, that sounds great. You know, I'm going to have to submit something because I want one of those patches. Hey, Sian, we have a couple of more questions. Are you willing to do a couple more questions? Okay.
Sure. Does the freeze-dried food still contain its nutrients? And is that what you're eating during this pandemic?
Yes. And so what's great about freeze-dried is that it's taking out, because right now we ship water and nutrients in the form of food around the world. But when you take out 98% of the water, you're just shipping the nutrients. So this keeps it, the corn is picked at its ripest part or time, and then it's freeze-dried. Because if you think about what fresh is, if something comes from halfway around the world, is it fresh? And think about all the things that we do to try to keep it fresh by the time you go to your supermarket and buy it. So you can imagine it's picked halfway around the world before it's ripe. We do all these things to try to keep it ripe. We put a lot of energy into keeping it fresh.
True.
Then we get it to our supermarket and we put a lot of energy in keeping it either fresh or frozen. And then you buy it and you bring it home and you try to keep it fresh as long as you can or frozen. And then if you don't get to it in time, it spoils and you throw it away. 30% of food gets wasted around the world. And in the United States, it's about 40%.
Yeah, yeah. And that's a real loss. That if we could just go in the way of freeze drying things, that would certainly preserve a lot of the energy and expense and effort that goes into it, and cost a lot less to ship things too.
And my whole thing is not to give up fresh food. I really love fresh and I have my own garden, but my whole thing is we should freeze dry food that we ship internationally or around the world and combine that freeze-dried food that you buy with locally sourced fresh fruits, meats, and vegetables. So you've got both the best of both worlds. And so I have replaced the things in my freezer. So people are like, really, freeze-dried? And I'm like, if you think about what's in your freezer right now, if you have frozen fruit or frozen vegetables, you can get freeze-dried versions that are shelf stable for years. You don't have to worry about freezer burn, and now you've taken that out of your freezer, and you are saving energy and all of those kinds of things.
I'm going to add a piece to that side that allows us to put this in the space context of launching stuff. One of the most expensive commodities that we launch into space, because water weighs 8 pounds per gallon. And that 8 pounds of water, that's going to take so much fuel that's going to be required to lift it off the planet, get out of the Earth's gravity well. And the more water we ship into space, the more expensive it is. If we can freeze dry or make the water someplace else, then that means we have fuel that we can sort of want to send to space. So freeze drying food is a really great way to go, and that really makes a huge difference. Hey, Si, I want to say thank you very much for joining us. It's been a real pleasure having you. It's great to see you. I got to come visit you when I'm out in Phoenix. And thanks a lot for answering our questions. What's your next adventure?
You know what? That's a good question. I just applied to potentially go on another Mars simulation at the Mars Desert Research Station. We'll see if we get selected for that. And then I'm supposed to do an ecology summer project in Belize with manatee, and I'm not sure if it's still going to go or not, but it's been a real pleasure being here. People can follow me at Dr. Sian Proctor on Instagram. I have Facebook Live. I'm running a show called Space Snacks on Facebook Live, and I want to have Derrick on that.
Oh, yes, that's right.
So please follow me and reach out to me and ask questions. And the website is www.mealsformars.com, and the Meals for Earth recipe contest is under the blog of that.
Super. So everybody who's listening, make sure you jump into that contest and you can get selected, maybe even be the winner in a category. Worst comes to worst, you'll get that wonderful patch that she's. Hey, Sian, thanks so much for being with us.
Thanks for having me, Derrick, and have a great night. Stay safe, everybody.
Good luck with everything. And thank you. See you soon on Space. Thanks a lot, Si. Okay,
Bye.
folks. That was my great friend, Sian Proctor, who is joining us tonight. We're glad she could be with us. And we'll have her back again sometime. We can talk about some more space exploration stuff. Now, I know you have a lot of questions. We want to get to your questions. And the other thing I want to do is I want to take you on a short tour through the, I'm going to reach out like this. I'm going to pull this all the way over here like stuff. And I know you're sort of looking up my nose right now. We'll see if we can fix that a little bit. There we go. But here's what I'm going to do, folks. I'm going to share my screen now, and I'm going to try to go out to Stellarium so that we can take a look at the sky tonight and talk about what's coming up next. Okay, so here we go. I've selected my window. I'm going to share my screen. Here we are. God. This is that great program I talked about called Stellarium, where I can control. What I'm going to do is I'm going to throw up a little bit of extra information for you. I'm going to go over here and I'm going to bring up the date time window. And you can see up here in the top corner, it's May 1st. So this is what the sky looks like for tomorrow night. And the time is almost 9 o'clock in the evening, 20 hours, 54 minutes. So that means it's 8:54. Just to kill a little bit of distraction here, we'll do that. Okay, great. And now we can take a look at the night sky. So here we are. We've got the date and the time. I'll get rid of that, so we don't need that. And you can see that we're looking, and you can see there's Venus high in the western sky, right over here, in the sort of like almost the west-northwestern sky right here. And it's near a group of bright stars that are right around here in this portion of the sky that are just setting. Now, the cool thing about this program is we can do some magic. It's very much like being in a planetarium. And here's what I'm going to do. If you'll you can watch the time change here. I'm going to go down here to the bottom of the screen where I have the control console for this. And I'm going to back things up. And here's what we're going to do. If you'll notice how the time is changing, we're moving back earlier in the evening. It's now coming up on 8:40 p.m. You can see how the sky is brightening over. As we get right out to here, what I'm going to do is I'm just going to halt everything right here. And the reason why is because you can see that this is just after sunset. As I said earlier, sunset now is at 7:55 p.m. And here at almost 8:30, it's not quite dark enough yet in the evening sky to see a lot. But of course, the first things that show up are the planets and the brightest stars. So now that you can see that, we're going to go forward in time. We'll speed it up just a little bit so we can get back to where we were. And we'll allow it to keep this speed as we're going on, just so you can see the change. I'm also going to show what these constellations and stars are out here. This is a group of stars that surround Orion the Hunter that's just about dropping below the horizon here. And I'll bring up some labels so you can see where they are. Here's the constellation Orion in here, Auriga's out here, Gemini, Canis Minor, and Canis Major, all out here sort of surrounding Orion along with Taurus. And I can give you some shapes so you can see that too. You can see what they look like. And here's what those outlines look like. So there's the belt of Orion right here, and just above Betelgeuse are these bright stars of the Gemini twins. The cool thing about observing the western sky at this time at 9 p.m. in the evening is that the twins now stand upright on the western horizon as time goes by. So Venus is right over here, the bright star Capella is over here, and these constellations are going to be disappearing from the sky quite soon. Over the next week or so, they will disappear. But you've heard me mention before that the way to begin looking at the sky is to start by pointing yourself toward the southern direction. If you're outside tomorrow evening, high in the southern sky, you'll find the moon. So don't forget to take your binoculars out tomorrow evening as the sky clears, or Saturday, and take a look at where the moon is. Now you notice that it's near this constellation, Leo the Lion. And Leo is the main constellation of the spring sky right now. So at 9 p.m., as you can see right here, I'm going to advance us right up to 9 p.m. There we go. And we're looking at where Leo is on the night of May the 1st. Now, if the sky is still cloudy tomorrow night, you can go out on Saturday night, May the 2nd, and see where the moon is. And I'm going to show you something really interesting right now. I'm going to shift this by 1 day, and I want you to see how the moon jumps from its position here to its new position, where it will be 1 day later at the same time. You ready? Here we go. There, you see that jump? That jump represents approximately 28th of the moon's orbit around the Earth. So in 1 day's time, this is how much movement the moon has from 1 day to the next. So here's May 1st. Let's go to tonight. Here's where it is tonight, even though the sky is cloudy for us here in the Delaware Valley. If you're someplace else around the country, hopefully you have clearer skies. Here's where the moon will be tomorrow night. Here's where the moon will be Saturday night, Sunday night, Monday night. So you can see how helpful and useful this particular Stellarium program is. And if you're interested in some of the stories that go with this program, of course, as I mentioned before, also provides these outlines so you can see the artistic shapes that go with the stories of the night sky as well. So this is a really handy program. Oops, I went the wrong way. This is a really handy program that works really well and allows us to see a tremendous amount in the night sky. And you'll even see, I've got some information up in the corner here about a particular star that I clicked on inadvertently. I'm going to do Arcturus so you can see what that looks like. And there you can see the ways in which it's registered in different catalogs, the type of star, and a lot of other information about that particular star. So it's a very, very handy and very, very helpful program. Okay, I'm going to stop sharing my screen now because I know we have questions. We need to come back and see if we can answer some more of these questions. So let me just bring my video back. Here we are. Okay, so now let's see if we can take some of your questions here.
Okay. What happens with the matter that's sucked into black holes?
Yeah, this is always a great question. What happens with the matter that's sucked into black holes? If you've seen any of the popular black hole movies that have been around, particularly a decade or so ago, some of the Walt Disney movies gave the idea that if you went into a black hole, if you were sucked into a black hole, you can actually travel through a black hole and end up in another portion of the galaxy, or the universe rather. And in fact, what actually happens to material that gets pulled toward a black hole is that material actually gets broken down into its constituent molecules and atoms. So the material actually breaks down. A lot of it is converted into energy, and is radiated away from the black hole. So we shouldn't think of a black hole as like a vacuum in space or an actual hole in space where things go down in and disappear and come out someplace else. The singularity that provides the gravitational pull brings material to it. That material often rotates around on the accretion disk where it's converted into energy and is radiated away. So that's what happens to almost all of that material. What's up next?
How many people have been in space in the past 100 years?
How many people have been in space in the past 100 years? Well, we don't even have to go back that far. Let's just go back about 60 years. The last time I looked up that information, which was not too long ago, I think the number is just over 500 people have been in space. I think that's about right around 500 people. You can look that number up, but over that period of time, that's not really a lot of people when you think about the fact that they typically only go in groups of 2 or 3 at a time. Now, the space shuttle missions that the United States operated from the early 1980s until the late 1990s, until the 2000s, I should say, those missions often had as many as 8 people or even 9 people on board space shuttle missions as they were going to and from during the construction of International Space Station. But that was unusual. So typically going to space in groups of 2 or 3, that's the way we've gotten up to around 500 people. What's up next?
What are the nations that are represented by the 6 people on space station?
Just a moment. Let's see if I can tell you what are the nationalities of the people that are represented on board space station right now. You know, these are really wonderful devices, these handheld devices that we have, these smartphones. And the reason why is because I have a program called How Many People Are in Space Right Now? And oh, right now, I'm sorry, I was wrong. The number is 3. It's not 6 right now. The number is 3. So let's find out where they are from. So there's Chris Cassidy from the United States, Anatoly Ivanishin, who's from Russia, and Ivan Wagner, who's also from Russia. And you can see their names right here. So we have 1 American and 2 Russians on board right now. I'm going to just check and make sure this is up to date. I'm almost positive it is. And as I say, you can check this very simply by going to nasa.gov, clicking on the International Space Station tab, and you can find out how many and who's on board, where they're from.
Why is Earth called Earth?
Why is Earth called Earth? Wow, that's a really tough question. You know why? Because that name has been known since antiquity. So we'd have to go back really far in time, and we'd have to dig up some obscure person to find out how we actually got to that name. I don't know how we got the name Earth, other than it's the stuff we're standing on. That's a piece of research you might be able to do a little bit better than I can right now, but give it a shot and see. It's like asking the question, why do we call it moon? Same kind of thing.
How does Hawking radiation work?
Oh my goodness, we're back to Hawking radiation again. Now, okay, I'm going to ask you just hold on one more week so we can talk about black holes all together. We did a little bit tonight, but I actually want to bring a guest on to talk about black holes so we can talk about all of the aspects of black holes and Hawking radiation too. So I'm going to ask you to hold on. I know you really want that question answered. We'll get to it. I promise we will get to it. Okay, so now let's just check a couple of things while we're going forward here. As I mentioned, International Space Station has a series of flybys or flyovers next week, but it's a series of very low and very short flyovers that are through the northern sky. And unfortunately, they are extraordinarily challenging views. And when I say low, I mean they're going to be close to the horizon, and most of them only last somewhere between 1 and 2.5, maybe 3 minutes in length. So they're going to be really, really hard to see for a number of different reasons. I'm not going to recommend them because they are difficult, but if you're up to it, you can get the details at heavens-above.com. It's a website that we've spoken of before that provides information for seeing International Space Station and other satellites. And you can also go to nasa.gov, where you can find that information as well under Spot the Station tab at nasa.gov. Now, The next evening flyovers are coming up around May 14th, May 15th, when we'll shift back from the morning sky back into the evening sky, and we'll again have good flyovers for everybody to be able to see without too much difficulty. So I just want to bring one more thing to your attention this evening, and that is I was talking a little bit about observing the moon. And observing the moon is a really cool thing to do. You have the next 4 or 5 days to catch the moon in its first quarter phase as it's moving, or just past first quarter before it gets to the full moon phase. I talked a little bit about using binoculars, but I really recommend that you take the opportunity to do it now. And the reason why is because the way the moon is illuminated right now makes it really, really wonderful to see. The shadows that are created in the way that the moon is illuminated right now allows us to see the dimensionality of ridges and craters really easily. And we can see their height and we can see the depth. You can see a lot of the features of the moon in a different kind of character. And with binoculars, of course, everything will appear nice and sharp and clear. So when you look with binoculars, don't look toward the brightest section of the moon. Look instead toward the edge of the moon where you can see the line that sort of separates the light half of the moon from the darker portion of the moon. Right along that line called the terminator is where you'll be able to see a lot of these really cool features looking really, really stark as they stand out from the surface of the moon. So remember, between now and full moon is the time to do this. If it's not clear tomorrow night, Friday, try it again Saturday night, Sunday night. Monday night will be the last night before it gets too bright for you to be able to see it. So that's a really great thing to do. As far as planets are concerned, Venus is in the evening sky, as I mentioned earlier. Right now, it has come to its brightest point in its visibility for this particular season. So make sure you see it tomorrow night, Saturday night, Sunday night, because as the weeks go on through May and into June, it's going to begin to dim and fall lower and lower in the sky, and we'll lose it again for this season. You won't be able to see it in the evening sky again for another year. In between, it will be in the pre-dawn sky in the morning. But the shift is going to be those planets that we can see in the morning sky now, Mars, Jupiter, and Saturn. Those are going to slowly make their way into the evening sky, and we'll have them through the summer. So catch them in the morning sky if you can. Make sure you catch Venus in the evening sky, and you'll have that whole set of planets that you will have learned and understand now, and you'll be ready for them when they come up in the summer. Okay, so we've had a great time this evening. I want to thank you for joining us this evening. We took just a few minutes to catch up. I wanted to say, take just a few minutes every day to catch up with what's happening in the night sky. You've had some really wonderful questions. So we have another question we can.
When they're in space and then revert when they come back to Earth?
That's a good question. Do astronauts age while they're in space? And does that age revert once they come back to Earth? Wow. Let's see. So on the general come back to Earth, for them, time passes just as it passes on Earth. It actually has more to do with how fast you're traveling through space, how you might age. So for astronauts that are only maybe 200 miles, 250 miles above Earth, they age at the same rate in space, just about as they do on Earth. And when they come back to Earth, they don't get younger because they're still moving forward in time. So they continue to age as time. One more?
What would happen if
That's a really cool question. I like that one. Let's see. Think about this. Here's some things to think about for that. If the sun went away, what would happen to us? Well, since the sun provides all of the light and heat that this solar system went away. Now, the sun also happens to be the gravitational center of our solar system. Its mass creates the gravity that holds all of the planets in orbit around it. So if we didn't have that gravitational center there, what do you think? I have a way that you can try this as an experiment on your own. Here's what you're going to need to do this. You're going to need a small bucket or a small plastic container. And what you'll have to do is punch some holes in the rim on both sides opposite each other. And the hole should be big enough that you can put a piece of string through. Now, once you have like a small plastic bucket, maybe it's a cottage cheese container that's been emptied or something like that, and you've put the holes near the rim on either side with the string through, now fill it with water. Halfway 3/4 will be fine. Indoors, you'll have to do it outside. Once you get it filled with water, go outside, and I want you to swing it around over your head as fast as you can, being careful not to spill the water, and then let go of the string. You figure out what's going to happen. There's an experiment you can do between now and next week. Don't yell at me if you get wet. I'm not responsible for that.
Break a window.
But you can try that. Right. And my producer says, be careful to do this away from windows or anything that can be harmed, but it'll be a fun thing that you can do. One more question.
It's about navigating through the Pacific Ocean, but stars are not in the same position from day to day. So is it actually reliable that they were able to navigate via the stars?
It's a question about Polynesian astronomers using stars to navigate around the Pacific Ocean basin. Yes, they did, and they sailed around because whatever season they wanted to sail, they had sets of stars that they could use to get them around the Pacific Ocean. But the coolest thing about the Polynesian navigators is not only did they use the stars, but they also used the ocean currents themselves to tell them if they were going in the proper direction or at which point in the journey they should change direction because of the way different ocean currents came into connection with each other. They also used birds that might be flying along migration routes and lots of other hints about the wind around them, and all of those different elements together help them to be able to navigate the Pacific Ocean basin with amazing, absolutely amazing accuracy. So much great stuff we can talk about, and we'll continue next week. Speaking of next week, guess what? We're going to talk about telescopes. Yep, that's right. The weather is just getting to the point where it'll be nice to be outside. You'll want to get a good look at those great planets this summer, and you either have a telescope at home already that you haven't figured out how to use, or you'd like to get a telescope. We're going to go through the basics you need to know about how to get a really good telescope and how to use the telescope you already have. So stay tuned for that next week. We'll also catch up with whatever cool things are happening in the sky. So thanks a lot for joining us tonight. Don't forget, check out our fi.edu page, the Franklin Institute's webpage, for other Franklin at Home programs. And that way you can have a whole retinue, a whole great collection of different activities that you can do, all science related. Don't forget, you can follow me on Twitter. @CoolAstronomer is my handle. I'll give you some daily updates of things you can see in the evening sky. And also remember, make sure you practice that social distancing and stay safe. Thanks for joining us. We'll see you again next week. Next week.